Hello my students, once again I'd like to welcome you to this great lesson under matrices. I told you we shall be having topic breakdowns every Tuesday, and so here we are. I'm teacher Kenya Innocent. Please, I will advise you to subscribe to my YouTube channel, that is teacher Kenya Innocent, and we shall be having much of this. So today I want to look at specifically matrices, and I've noted out some of the things that are very common that are disturbing us with the matrices. We are beginning with the order of the matrix, what we can see part A. Then we have addition and subtraction of matrices. We have scalar multiplication of matrices. We have multiplication of matrices. There is inverse of a matrix, and the final application of matrices. So I told you matrices is one of the few topics that are highly set as far as item number 3 is concerned, where we have data collection and probability as the theme. So under that item number 3 and 4, we have data collection, data and probability is the theme. We have topics like data collection and presentation. We have graphs, we have set theory, matrices and probability. But for this case here, you're seeing that there are only 5 topics to occupy item number 3 and item number 4, which means we must get all these 5. Being that they are few, so we must have all the 5 with us if we are to be able to pass item number 3 and 4. So specifically, I'm going to be speaking about matrices, as you can see, and what are prepared for use. The order of the matrix, addition and subtraction of matrices. Then we have scalar multiplication of matrices. Then we have inverse of a matrix and application of matrices. Let's go to the next slide. Now next slide, we are beginning with the order of the matrix. We still have people that are confused with the order of the matrices. Now look at this. If you look at where my pointer is, there is something like we have given a matrix A equals to SC BD. Hope you can see. So from here, I do some arrows. There is a red arrow which is standing for a row, like you're seeing there. Then you have a blue arrow which is standing for the column. So any movements, are you seeing from the left to the right, that is, we are moving in terms of a row. So that is a row. And the column, we are moving from up and down. Excuse me. So if you look at this, we have the row in our red color, then the column is appearing in the blue color. And the order of the matrix is normally given by row, by column. You say row, that times column. So we normally speak it as row by column. So how we get the rows? We start by movements from the left to the right, like I've shown you here in this arrow. So the moment you move in that direction, that means you're moving, you're making an order of the matrix. So it is a row by column, which means that you count how many rows we have, 1 and 2, and the columns 1 and 2. So in other words, our matrix A is having an order of a 2 by 2 matrix. Okay, we are going to find a lot of matrices that we shall be looking at with their different orders and their rows. We all know how to count this, but some people are confused which is the row, which is the column. So I've shown you with those red arrow, wherever you see that red arrow, that is a row, and the blue arrow is standing for the column. Okay, let us continue. We have some examples here. Oh my goodness. The title here is not very clear. Okay. Here we are looking at some examples of orders of the matrices of stating. We want to state the order of matrices. However, I didn't just put the title there, but here we're looking at examples, and from this idea here, so we are just coming to this to look at the order of matrices. If you look at matrix A, we are write down the order of the following matrices. We have A, which is 2, 3, 5, 6. So if you can count 1, 2, then you go to the columns 1 and 2. So if you can see from our responses that order of a matrix, model matrix A is 2, 2 by 2. Then come to matrix B, which is here. How many rows are there? We start by movements from the left to the right. Just know that all your counting should start from the movements from the left to the right. So if you look at matrix B, how many should be moved from the left to right? We only have one row. So it is 1 by how many columns? 1, 2, 3. So that's why I have matrix B equaling to 1 by 3. That is its order. So we have a question here. What about matrix C, matrix D, matrix E, and matrix F? Please answer that work, and you're free to WhatsApp me on 0781 82 1076, and I'll be responding to you, and I'll be scoring that. I'll be marking your work. Okay, that's all I can give you about the order, but still there's an open opportunity. And those who have not joined my WhatsApp group, you have the TBI online school. You can enroll, please. You can just text me on my WhatsApp number, which is 0781 82 1076, and I'll be responding to you, and I'll be adding to the group where people are discussing a lot of mathematics and chemistry. Okay, let us go to the addition and subtraction of matrices as the next part of what we said we must look at. We are saying that note, there's a very wonderful note here for addition and subtraction. For 2 or more matrices to be added or multiplied, they should have the same order, i.e. same number of rows and columns. Now this is a very wonderful principle if it comes to addition and subtraction of matrices. They must have the same order. If a matrix can only be added to the other if at all they have the same order. A matrix can be subtracted from the other if at all they have the same order. And what do you mean having the same order? Same number of rows and the same number of columns. So I say that you consider matrices A and B below, where I have A equal to A, B, C, D, E, F, G, H. Now in addition, you must look at an entry. We consider entries here, the order of the entries. The first entry added in the first entry. Hope you can see in the first row. Second entry in the first row, second entry in the first row. So that's why I have A plus E, then we have C, G, we have B, F, and likewise we have D and H. Likewise to subtraction, again look at that order of the entries. The way the order of the entries appears is the way they are added or they are subtracted. So it depends on the entries given and their orders. Don't change any order. That's why I said that the condition for addition and subtraction should be that the matrices should be having the same number of rows and the same number of columns. Examples are here. Work out the following. Given A equals to 2, 4, 5, 7, and matrix B is negative 6, 5, 3, 2. We are required to find A plus B and A minus B. So from here, what I've told you, again, before that order, the order of the entries is what matters. Just for the order A, the first entry is 2, and the first entry in B is negative 6. So add the 2. Like that, and like that. Okay, then let's go to scalar multiplication of matrices. In fact, all the examples we've just looked at, we've been talking about here, I will need to see them worked out, and you say you draft your work very well and send it via my WhatsApp on 0781 82 1076. I'll be answering you. Okay, then let's go here, scalar multiplication. Now people have some challenges with scalar multiplication and the multiplication of matrices. When a matrix is multiplied by a scalar, we just get an integer, any value, to multiply the whole of the matrix. So like you see, we have here, we are saying that when a matrix is multiplied by a scalar, the scalar multiplies all the entries in the given matrix. So consider matrices A and B below we have A equal to A, B, C, D, and B equals to E, F, G, H. Then 2A. So this is 2 is the scalar, and it is multiplying this matrix. So you can see 2 times A, 2 times B. So that means the 2 is going to multiply all the entries in matrix A. Likewise, 5B equals to 5E, 5G, 5F, 5H. So it multiplies all the entries inside here. Examples, work out the following. Given A equals to 2, 4, 5, 7, negative 5, 6, 5, 3, 2. So you'll find 3A plus 6B. How shall we get 3A? 3A is 3 multiplying the whole of the entries in matrix A. Then 6B, we shall again have 6 multiplying all the entries here. Then the resultant matrices shall be added, and we shall be getting our answer. So that is also an example which I need people to work out and send on my WhatsApp number here, which is 0781 82 1076. Don't forget to subscribe to that YouTube channel. Okay, let us continue. From here, let us go to the next slide. Yeah, we are going to multiplication. Now we've already done the multiplication of a matrix by a scalar. Now we have what you call multiplication of matrices alone. And here we are saying that, note, for two matrices to be multiplied, the number of columns in the first matrix must be equaling to the number of rows in the second matrix, i.e. they must be compatible. Now, this is a very, very wonderful principle that all people that are going to do, if you're going to do anything like matrix multiplication, you must get this principle. And that principle says that for two matrices to be multiplied, the number of columns in the first matrix should be equal to the number of rows in the second matrix. And here we are considering matrices A and B. I told you when you're writing the order, we first move from the left to the right, all the rows, 1, 2, and 3. So order of A is 3 by 3. What about order of B? Just counted the rows. Let's count also the columns. 1, 2, 3. So we have order of A as 3 by 3. What about B? Number of rows first, 1, 2, 3. Which means that those are 3 rows. Then columns 1, 2, 3, and 4. So we have 3 by 4. Being that's why I put this in red. That being that these two, the number of columns in the first matrix is equal to the number of rows in the second matrix, so they are compatible, and therefore they can be multiplied. Let's make this and see. Since the number of columns in the second matrix is equal to the number of rows in the second matrix, the two matrices are compatible and therefore can be multiplied. Okay, let us continue in the next slide. So let us solve it. We have matrix A according to those figures, the way you're seeing them, and the B. Now there is a problem here. Some of the people don't know how to multiply matrices. But the principle in the multiplication of matrices is that we multiply a row by a column, and every row must multiply every column. Now let's look at this in this way. I try to change the color of this because I'm saying that a row by column. So we have the first row as 2, 5, 4, and the first column here is 2, 5, 6. So we move in the means of row multiplied by column, figure by figure. So look at this. In our first entry, so we are saying that so A multiplied by B equals to what? 2 times 2. Hope you can see. Then we got 5 times 5. This is a row. A row here is 2, 5, 4, and the column is 2, 5, 6. So every figure in the order of their entries must multiply the other as we are adding. That's why we have 2 times 2 here plus 5 multiplied by 5, and again 4 multiplied by 6. So that is the row in the first matrix is multiplying a column in the second matrix in the order of their entries. What do I mean? The first figure, second figure, third figure. So we do that for all of the the rows here. In the second place now, we have 2. Again, this row comes back and multiplies the second column. Likewise, again, that first row will come back and multiply the third column, and this again first row will multiply the fourth column. That's why I have all of these. We have that entry there, we have this entry here, we have this entry here, and this entry here. What makes up the whole of this first thing you're seeing here? What is making it, is what we are calling the first row and the first matrix. So that's why you're seeing the first entry, second entry, third entry, fourth entry, because it's one row multiplying, getting multiplied to every column. Then likewise, if we are done with issues with the first row, let's go the second row again, that matrix. Second row is what? 482. So 482 must again multiply these four columns. So we have 4 times 2, as you can see, then 8 times 5, 2 times 4, and likewise the rest of them. I will not go through the whole of that, but that's the principle we majorly follow. So please follow it and continue with that work. Don't forget to subscribe to my YouTube channel. Okay, let us continue again with the following examples. We are saying that work out the following. Given that A equals 245, then 587. Hope you can see with the entries in matrix A. Then you have matrix B and C. The question says, with the reason, which of the following sets of matrices can be multiplied and work out them? You have Roman A, B, A, B, C, C, B, S, C, C, A. So a set that can be multiplied is the set that fulfills the condition of compatibility. And we say that when are they compatible? When the number of columns in the second matrix in the first matrix is equal to the number of rows in the second matrix. So if you can look at those sets there, those pairs of matrices given, if you find out that any of them are compatible, then those ones can be multiplied. So please do work out with them and forward them to my WhatsApp number, and I'll be marking them right from here. Okay, next slide. We have application now application of matrices. This is the major thing as far as matrices are concerned, because if you look at matrix multiplication is what covers the whole of this application. So our major emphasis is the application part of it, because this is where a scenario comes from. And like you can see my example, we are saying that this involves the real life application of matrix operations. What you mean by matrix operations? That is addition, subtraction, scalar multiplication, and multiplication of matrices. So from there, I've just drafted for you a scenario which you want to go through very quickly. Then we shall just summarize it, and I'll be waiting for responses from you. Look at that example. It says 3 children, Sarah, Joan, and Moses, made their shopping lists for back to school. Sarah wanted 5 pens, 6 books, 3 pencils, and 1 geometry set. Joan wanted 4 pens, 7 books, 2 pencils, while Moses wanted 4 pens, 1 geometry set, and 4 books. The cost of the pen, book, pencil, and the geometry set are 1,000 Ghana shillings, 6,500 Ghana shillings, 500 Ghana shillings, and 3,500 Ghana shillings, respectively. Their fathers requested them to arrange all this in the form of rows and columns for easy recording, but they are finding it hard. These children also found out that the prices per each item had increased by 500 Ghana shillings for a geometry set and by 100 Ghana shillings for the rest of the items compared to the previous term, and they are confused of finding the increase in the total amount in comparison to the present term. Okay, now if you look at that, we may not need to go through all those too much words, but if you want to pass well matrices, the major thing here is to summarize the information given an item, because you cannot carry all this in your head and just start forming matrices. You're more likely to get errors. But a person who has drawn a table, we just collected the information from the table and will be going directly to what? To a matrix copy from the table. So I advise you, the moment you find out, to discover that this is more so, if it is item number 3 or item number 4, and you find out such information, just know you're going to be dealing with the matrices. That's why yesterday I was emphasizing an issue of the elements of construct, because you know exactly what will be answering and in which item. So from here, when you look at that application, our first step is to make a summary. And making a summary, we shall break a simple table that has the items to be bought and the owners of the items. Maybe we shall also have another table that has the costs, and then we shall be going to their task. Okay, next slide. What is the task saying? Arrange the items and the costs in the form of rows and columns. In the form of rows and columns. That one leads you exactly to matrices. There is no way you can dodge out that. Then Roman 2 says, use the arrangements above to determine the total cost of the items. That one will lead us, because if you have the items, you have their cost automatically. That is multiplication. By the way, I've seen many people in this number of matrices just manipulating, just calculating how many sets did they buy, someone gets the total, how many pesos, that one I don't mark. What I mark is you applying matrix multiplication. Now for this case here, it is an application of matrix multiplication. So the moment you arrange the items and the costs in the form of rows and columns, you must use the information you collected and multiply those two matrices. So that is what you must do. Get the matrices, multiply them, and then after you'll be getting the answers. But just normal manipulations will not give you any mark. There will not carry any mark from there. So we are saying use the arrangements about to determine the total cost of the items, and then part B says help these children determine the increase in the amount in comparison to the present time. Okay, let us look at our summary. What I tried to come up with, I didn't complete, but at least I wanted to show you how we come up with these kinds of summaries so that we can be able to pass this item. This is one of the cheapest items that all of us should pass if it comes to an examination. Okay, so look at our summary. This is the summary I tried to come out with. I told you that our summary should be a table. Come up with a simple table. You know the items there. Identify the items. For example, we had the pens, we had the books, we had the pencils, and also had the geometry set. Then which parties were involved in buying those items? Who are the people? We have Sarah, we have Joan, and Moses. How many pens did Sarah buy? You can see. How many books did she buy? So being that you have this table, now everything will be summarized here. And where you say 0, that means that person didn't possess that item. Because you have Joan with a 0 under geometry set, and in our scenario, Joan didn't buy any geometry set. What about the table of the costs for each item? What are the items we have? We have a pen, we have a book, we have a pencil, and a geometry set. And their costs are given. That is per item. That a pen costs 1,000. A book costs 6,500. And the pencil costs 500. What about the geometry set? 3,500. That is a single item. So from there, because I have my table, now this one will become very easy for me to have a matrix out of it. Actually, I'll just put everything off the table. It's like I'll put this marking, the lines, and I just put now brackets. Because again, I said item matrix. You know, in matrices it's very, very important to put titles, because putting a title there will earn you a mark that is presentation equals to 1, because you put that. So I advise you, whether it will be awarded or not awarded, I advise you at least put a simple title. So say item matrix, then come identify the items. We have pens, books, pencils, and geometry set. So from there, who are buying? Sarah, Joan, and Moses. So it's our matrix. It looks nice, very labeled, and the titles there. Then what you should not forget is its order. A mark is awarded for this order most of the times. So we know, I told you, we don't want examiners to have excuses of denying us marks. So do anything that will not cost you, anything that will not let you leave any mark and not given to you. So from here we come up with the item matrix. Hope you can see it very clear, labeled well, and that one leads us to the arrangement that is listed in an item in a row and columns. Then also I came to cost matrix. Hope you can see we have cost under that here. Could be I didn't label the items here, but they are supposed to be labeled from this table. You can see pen, so I must have pen here. You can put a book here, pencil, and the geometry set. So that is the cost matrix. And what is its order? 4 by 1. By the way, I've not talked about the order for item matrix. We said we count from the left to right. That's the first. Left to right. Just have in your mind that whenever I'm going to write the order, I begin from the left to right, and counting from left to right, that is a what? That is a row. 1, 2, and 3. Right, your 3. Put a multiplication sign times, which we denounce at normally denounce it as a by. So what about 4? 1, 2, 3, and 4. So that is 3 by 4. What about cost matrix? Again, 1, 2, 3, 4. Right, your 4 by how many rows? It is only 1 row. So it becomes a 4 by 1 matrix and a cost matrix. So from there, now you have easily determined what we need right from here. The matrices are already formed, and the mere fact that they're formed, you know what is next. Of course, will be multiplication. 2, look at their compatibility. Look at their compatibility. Are they compatible? Why did we say that matrix? When did we say that matrices are compatible? They are only compatible for multiplication if the number of columns in the first matrix is equaling to the number of rows in the second matrix. Therefore, those ones can be multiplied. Please do so. Continue with that item. I would love to have your responses and submitted for marking, and results shall be given to you. So thank you for watching. I just urge you to subscribe please to my YouTube channel, that is Teacher Bukanya Innocent, and also text me, forward your work to my WhatsApp number, that is 0781 82 10 76. So thank you for watching. Let us meet again for another topic. If there is anything, maybe you have not talked about the inverse of the matrix, where we need to get 1 over its determinant multiplied by its adjunct or its adjoint, but I think people that will need help from there will be texting me. Maybe another application here I've not talked about is the solving simultaneous equations using matrix method. However, for this case for today, let's pause it from there. Let us meet again. I'll be ready for your submissions.